to the lecture for our class on knowledge and belief, and this is going to be a introduction to the paper Mutual Beliefs of Multiple Conversants, a computational model of collaboration in air traffic control. So what I want to say about this paper is by way of providing you with guidance for reading the paper. You'll have to read the paper and understand it for yourself, so it's not going to be a paragraph by paragraph explanation. The motivation of the paper is basically that there's a model of the way that people understand each other and know that they understand each other. This paper is a demonstration that the model could be implemented in a multi-agent system. Now, the domain of this implementation is air traffic control. And the reason that air traffic control is suitable is because the acts are well understood. It's not like the agents are talking about a movie they saw or some kind of random thing. Rather, it's very precise and makes it relatively easy to represent what the agents are saying. That being said, the importance or the significance of the paper isn't the representation of air traffic control, but rather the way in which the beliefs and the mutuality of beliefs are represented in prologue. Of course, it could have been done in some other language, but for our purposes, this works out pretty well because we can understand the representation. Now, the motivation section of the paper describes a little bit about why this model ought to be implemented, and then goes on to talk about the ATC domain. We talked in class about beliefs and knowledge, and in this case we're really going to be talking only about beliefs in the sense that all we care about is modeling what the agent thinks, and in particular we're thinking about or modeling what the agent thinks about what the other person thinks. So in that sense, knowledge is sort of irrelevant. We're really thinking about do the agents know that they're on the right track? The other thing to think about in this paper is that there are overhearers. That is, in air traffic control, it's kind of like a party line. The agents, the pilots and the air traffic controllers do talk to each other directly, but there are other pilots listening in, and if a pilot talks to another pilot, then the air traffic controller is listening in. So in this sense, the air traffic control domain provides a way for us to model situations where some people know that the beliefs are mutually understood or expressed, and others where they know that other people believe them mutually, but those people don't know that they believe them mutually, and so forth. It provides for a range of kinds of agents or situations of agents. Now, when we're looking at the code in prologue, the first example in the paper is that of where somebody has a belief that Sundance 512, which is an aircraft airline flight, is at 5,000 feet, and that belief is true. And then the rest of the predicate is about who believes it mutually. So what this says is, in the example, is that approach believes it individually, Sundance 512 believes it, and approach and Sundance 512 both believe that they've mutually established this belief. So that's the idea. There's going to be a discussion a little bit later in the paper about speech acts. We'll talk about speech acts in detail in a future class, but for our purposes here, the thing to know is these are kinds of acts that people take in conversations, and these are the specialized acts that that air traffic controllers and pilots will take. So that's a little bit of an introduction to the paper. See if you can figure out exactly what the paper stands for, number one, and number two, see if you can understand how the representation of the beliefs implements this general notion of mutuality of belief. And here I'm going to be introducing the paper by Lebrew, Finan, and Peng on the current landscape of agent communication languages. So this isn't a kind of paper where I need you to understand all the details of every language, and probably not even the details of the comparisons between the two agent communication languages that the authors compare. But I do need you to understand some of the broader issues, some of the background, and why this kind of thing is important. So the introduction is actually pretty interesting, and it describes some of the rationale why we might want to have an agent communication language. And in section 2, the authors describe what it means to have an agent communication language, how it works sort of technically. In our class, because our agents are going to be operating pretty much out of the same program, we're not going to need anything particularly complex. But nevertheless, we are going to have a standard set of acts or things that the agents can do, and that will be our agent communication language. Now, we're going to be doing a sort of simplified version where we set up our own language. What these authors are describing are more universal description languages, which will be used or would be used by people in different locations or different groups who are trying to have their agents talk to each other. So they describe in section 3 a little bit of the background in terms of how these agent description languages were developed. And it's interesting in the sense that you'll be able to see the kinds of issues that turned out to be important and some issues turned out not to be important. The best known agent description language, which we'll start to introduce in section 4, is KQML. And it's it doesn't describe the content of the interactions any more than HTML as a standard describes the content of a web page. It does provide a syntactic and, as we'll see in a minute, semantic framework for describing what agents can say to each other. Now, the language KQML, the syntax is based on Lisp, and there's, for those of you who know Lisp, the syntax will be pretty clear. We can reproduce the same thing in Prolog if we wanted. It's just a question of different parenthesization and using commas instead of spaces and so forth. The syntax is pretty straightforward. And I think it's important for you to be able to at least understand what, for instance, the ask one and the tell examples on page 4 of the paper are trying to describe. In other words, what is the content of this message? They also describe the semantics for KQML. For our purposes, we just want to know that we can define these semantics formally. We're going to use an informal semantics in class, but the key for us for this, in terms of looking this paper, is in page 5, where we see the preconditions for agent A, the preconditions for agent B, and then the postconditions for A and B, and then finally the completion. So for an act, tell A, B, X, where X is what's being told. And if you can think about the preconditions and the postconditions as being the state of the knowledge base of the agents before and after the action of telling, then you can get a pretty intuitive feel of how this works, and you can sort of get it from looking at the completion, which is no B believes AX. So in other words, B knows that A believes X because A has just told B X. Then this other representation for agent communication is the Foundation for Intelligent Physical Agents, FIPA, and their language, the FIPA ACL, Agent Communication Language, it has this very similar syntax. So you'll see how that works. Now they describe in particular how KQML is different in terms of its semantics, and when you get to section 6, the authors compare the agent communication languages. So here, I think the important thing to understand is the kinds of things that they compare, as opposed to the specific comparisons, which gets a little technical for our purposes. And then if we, not worrying about implementation so much, but we skip to section 8 of the paper, the authors talk about agent communication languages and the issues that are raised. These are the kinds of things that continue to be issues in artificial intelligence right through the present. So that's a little bit of an intro to the LeBrew, Finan, and Peng paper, and we'll talk about it in class.